In this lecture, we're going to start implementing the state pattern for the enemy. You may be wondering, why aren't we implementing the same pattern for the player? Unlike enemies, players won't have many states. There is an idea of over-engineering something. Applying the state pattern to the player would be excessive. However, nothing is stopping you from applying it to the player. You may want to consider this option if you plan on expanding our game. For now, let's focus on the enemy. So, where do we begin? Currently, the enemy is being controlled from a single script called enemy controller. The state pattern recommends splitting each state into a separate class. Technically, we could stick to a single class, but our code would easily become bloated. One class per state is the way to go. Before creating a state, we should establish a base template. Our enemies are going to have multiple states. Therefore, we must create multiple class files. In each class, we should be consistent with the structure. If we aren't, we may experience issues that could have been avoided. I think this is the perfect opportunity for an abstract class. As a reminder, abstract classes are a great way to create rules for writing a class. All states should follow the rules established by an abstract class. This will reduce the number of potential errors that could arise due to inconsistency. Let's get started. Inside the character folder, create a new script called AI-base-state. Next, open this file. Clear the contents of this file. We're starting fresh. This class will not be added as a component to the object. As always, let's create a namespace to prevent a naming collision. Set the namespace name to rpg.character. Next, define a public abstract class called AI-base-state. The name of the class should match the file name. Let's define two methods. There aren't rules for what methods should be defined in a state. Generally speaking, developers will define two methods for entering the state and updating the state. The enterState method is responsible for preparing the state with data. For example, you may need to grab references to components or other game objects. As for the updateState method, this method is responsible for handling updates while being in the state. Like I said before, you don't have to define these methods, but they can be a great starting point for most states. In the class, define a public abstract method called enterState. Next, define another public abstract method called updateState. To reiterate, the enterState should be called up for setting the new state. For example, we may need to grab the movement component when the enemy is chasing the player. This component should be grabbed after the enemy switches to the chase state. If we need to prepare data, that task should be performed from within this method. As for the updateState, this method should be responsible for updating the object on every frame. Building on top of the previous example, we should update the enemy's position while the player is within chasing range. There's one more piece of information missing. At the moment, our states will not have access to the enemy's data. Keep in mind, states are not going to be components. Therefore, we must pass on data from our components to our state classes. Let's accept this data as a parameter. In both methods, add a parameter called enemy. Its type will be the enemy controller class. The enemy controller component will be responsible for activating and switching between states. In addition, controllers are considered to be the brain of a game object. I think it makes sense to pass on this controller to our state. Generally, controllers will have access to everything. Let's open the enemy controller class. At the top of the class, we have two variables called chase and attack. Both pieces of information will be helpful in different states. By passing this class onto our state, they will have access to these variables. In the next lecture, let's create a state based on our abstract class.